almost positive I did that. I guess I did. Oh, Scheiße. Oh, it's got me cussing in German now. I guess that's something for something. We can do a real quick recap anyway, because this isn't really anything more than we did on Wednesday. So you got two methods. Using the first one because we have to, because we can't use the second one, we get no outliers. But Patrick's concern about this over here, Patrick's concern about that little hump over there is a good concern, I think. I think it's a very, very good concern. So it would be awesome if we had another way of measuring outlier behavior. And the thing about this is, when we first started talking about outliers, when we first started mentioning outliers, you guys immediately went to the big ones and the small ones. You didn't think about looking in between, because most of the data sets that we had, even if they were skewed, they were humpy, single humpy. They weren't double humpy like this data set is. So everything we've been talking about, inadvertently or not, whether you use the mean, whether you use the median, it was all based on the idea that somehow these things have a single hump and a tail, or a tail and a single hump, or a tail and a hump and a tail, and there was always some kind of a mounding of data in one place. But what happens now? What happens now? Well, Patrick, go.
Oh no.
Push your sleeve up. Push your sleeve up. I'm sorry, I'm not getting activity, that's emotion. There is a third way, and this actually ties into the back half of this course beautifully, and it ties into 244 perfectly. And this is, I don't know what to call this, other than to call it, I don't know if your book calls it this, the old textbook I used to calls it the rare event, it's got a lot of E's, rare event identification. It calls it the rare event. It says, it actually ties into the beautiful definition of what an outlier is. An outlier is something that shouldn't have happened because it's unusual. But if it does happen, that's what makes it unusual, because it shouldn't have happened. It shouldn't have happened, that means it rarely happens. So the kind of understood cutoff for that is anything that happens. Now this is the given. This is the percentage that is now used in academia, in research papers, in journals and everything. Happens less than 5% of the time. Is considered unusual. And since it's considered unusual, we can then call it an outlier. Because that's the definition of unusual. It's atypical. It's atypical. So, this doesn't care where the unusualness is. This doesn't care if the unusualness is the lowest data point, or is the uppermost data point, or maybe is right in the middle like this one appears to be, or those two appear to be. Maybe that's a 1. That 1 appears to be. It just says if it happens rarely as a function of percentage of occurrence, nothing to do with shape, nothing to do with a box plot, no histogram, just look at the data and say, okay, what frequency of time did it occur? All right, well, let's see. Let's see. We got 1, 3, that's 4, 11, 15, 25. We got 25 occur. That's a sum of 25. 25 votes on that day. Fair enough? That means each of you is what percent of the whole? 4. 4% of the whole. Each one of you is 1/25th, which as a fraction is 4%. 1/25th is 4 100ths. So by that definition, you're an outlier, and you're an outlier. Because you happened rarely compared to everyone else. Not compared left to right, not compared functioning on its average, but just completely based on where the commonalities came from. See what I'm getting at there? Now sometimes these agree. Sometimes the rare ones are in the tails of a bell curve. For example, what percent is outside 2 standard deviations on a bell curve? 5%. Which means if you're out there in the tail, you should have happened less than 5% of the time. Which means there's a direct correlation between number 2 and number 3. If you're outside of 2 standard deviations, you automatically have happened less than 5% of the time. Boom, perfect correlation. But that doesn't mean that if you happened less than 5% of the time, you were outside of 2 standard deviations. You see that? That's a converse thing. You see what I just said right there? If you're outside of 2 standard deviations on a bell curve, then you definitely happen less than 5% of the time. Conversely, if you happened less than 5% of the time, that does not mean that you're outside of 2 standard deviations on the bell curve. Matter of fact, this guy right here would be well within 2 standard deviations on the non-bell curve that this thing actually is. Did you guys buy that? But we wouldn't go that route because the average for this thing would be somewhere kind of alien, like in here. I mean, how much of an average is that? Not really. Not really much of an average. Christina?
I don't know if this is a stupid question.
It's not.
Okay. You know the line of best fit when you're graphing, is there a possible way to do that to the bell curve? Because that second spike bugs me more than the one.
It does me.
Oh, that second spike?
It does. It
Yes.
bothers me.
And this makes me rethink my emphasis up till this point. Because if data, when I see data like that, I'm like, it's freaking cool. And you guys see data like that, you're like, oh my god. I want you to be able to look at any data set and have a set of tools to deal with it. It's just that this was convenient, and I'm happy about this. That I was planning on talking about this anyway, and you guys gave me the perfect data set to prove why we actually care about it. Because it doesn't fit anything we've been talking about so far. Now, I don't want to brag, seriously, I don't want to brag. But here's the deal. I can't do a line of best fit with it, and here's why. Here's why. A line of best fit, what's what we were doing in Math 105. We were plotting my distances as a function of my time. We're doing that today, right? My distances as a function of my time. It's called bivariate data. You need 2, an x and a y. We only have an x here. I know it seems like we have an x and a y with frequencies, but that's not a data. That's just how many of these data points. So in order to do a best fit, we'd have to have some kind of a y coordinate to deal with. Now, one thing we could do is what's called a normal quantile plot, which kind of forces I'll show you again. It forces, turn that one off and leave you on, but switch it over to you. Perfect. No, but I can't. That's right, I can't do this. This is what I have to write the program for. I have to write, the problem with a normal quantile plot is it compares raw data to what a bell curve should look like. And it graphs you a best fit line based on that. But the TI's short-sightedness, unfortunately, only allows you to do it if you have raw data. This is why I have to write that program. So you can kind of finagle around it, Christina, but it's not going to make you feel any better about that thing out there, unfortunately. You're still going to have to, oh God.
I just know intellectually I can draw one, so.
Of course, absolutely. The problem is we have to we don't want to force this to be something it's not. I love the fact that it looks like this. I love the fact that it looks like this. And I love the fact that we have a tool to deal with it. You can use any of the methods you want. If you guys took a look at that and say, I think that's bell curved enough, okay, that's fine. As long as you run the calculations based off that, I got no gripe with that. Now my question asks you to do my actuary. But if you want to call that a bell curve and successfully, finish off your conclusion on what are outliers based on that, that's as long as you do it correctly, I don't care. I don't care. I would not call that, in my opinion, that's not bell curved enough. In my opinion, you could also call it, as a fourth method, I won't write it down because I don't want you to trouble yourself over this. You could also look at this as 2 different data sets. The people that guessed up to here, or even up to here, and the people that guessed over here. Now, rather than calling that a fourth method, because I don't want to just inundate you with that, realize that's a possibility. Realize that's a possibility. And I want to wrap up our discussion with why we even care. Why do we even care about outliers? Why do we care about them? Why did I create this section? If you look in your book, there is no outlier section. I made this section up. Why do we care about them?
Well, they happen. They're still events.
They're still events, and why do we care about them?
They skew the data.
They can skew the data. Good. Let's turn this off. Turn the screen back on. And let's make a list of why we care. Why would I torture you? Why would I torture you with an extra section? 8 sections isn't enough. I gotta go with 9.
They just don't represent the majority.
Hold that thought. That's another reason. I like both of these. Let's get them one by one. Why do we care about outliers? As I was going through the Tampa airport on the way into Florida on Saturday, whatever the hell that was, Friday, I saw Malcolm Gladwell's books. He has 4 of them out now. 3 of them are called Tipping Point, Blink, and Outliers. One of his books is called Outliers. It was sitting there in the window.
I did see that.
He's got a 4th one now, which I don't remember. But why do we care about outliers? Number 1, if they're extreme. So if they're extreme, meaning far left or far right, okay, if they're extreme, I'm putting in quotes, at the outside of the distribution, they can skew. And in particular, they're most likely going to skew X bar and S. Usually the median is not going to care too much, as long as you don't have a whole lot of them. If you've got a bunch of them,
And just those two?
X bar and S, yeah, because those are the only two that are affected by extreme values. The median is resistant to them. The trimmed mean is resistant to them. But the actual mean and the standard deviation, because it's based on the mean, are going to get pulled by those extreme values. Then you have to ask yourself, okay, if I've got them, what do I do with them? And this is not an easy question to answer, just so you know. What do I do with outliers if I've got them?
Stick them somewhere.
Stick them somewhere. So one thing, what to do with them? I'm gonna go with a. I think we have to get 2 and 3 maybe to talk about. But what do we do with them? So Tiff's question is, stick them somewhere.
I'm aware of it somewhere.
One thing you do is don't throw them away.
Okay.
Now,
I
Sean's
don't
like, I don't like that.
I don't like it at all.
Danny's not like that. I don't like that either, unless what? What could one explanation of an extreme data point be? I tried to hint at this on your last in-class exam with the bags of chips, but I think I hit it too well in my attempt to try to make it. There was the bags of chips. I gave you a block of data. These are the bags of blah chips. And I said, there was one, supposed to have one bag that was supposed to be 45.9, was actually 4.6, which would have clearly been an outlier. Why do you think that one bag was 4.6 instead of 45.9? What's one logical explanation of why it's 4.6? Think outside of a math class, please.
Okay.
Probably manufacturing.
Nick, it's a defect, right? If it's a defective data point, would you feel okay about throwing it away then? Absolutely, you can dump it, but I would only dump it if you can prove the data point was faulty, right? If you can prove the data was somehow flawed. If you can prove that it's flawed, throw it out. Now, the exact converse of this, it's funny, on this trip I was reading the book Wheelmen, which is the story of Lance Armstrong and all the doping that happened in the Tour de France over the past. I stopped watching it back about 6 years ago because it was getting so rampant. Apparently it happened way before that. People used to take cocaine as a stimulant to win the Tour de France before dying on the side of the road. Anyway, those guys, when they were getting nailed, Tyler Hamilton, for example, Lance never came out until relatively recently, but Floyd Landis, Tyler Hamilton, Ivan Basso, a lot of these guys that were getting nailed for positive drug tests kept saying, no, that test was done wrong. No, that test was done wrong. No, that test was done wrong. Well, the problem with that is, if all of their tests are being done wrong, are they outliers anymore? If they're all being done wrong, they must all be being done correctly. Because the test can't be wrong every single time if the test has any validity, which it's been shown to have. So they're trying to use the outlier defense. The problem is they're all trying to use the outlier defense, which is actually proving the point that they're probably all guilty of it. One guy out of 100, one guy out of 1,000, I can totally see that point. Your last project deals with this, FYI, false positives and false negatives, it totally deals with that. But the idea is they can't all be wrong, because you can't use an outlier defense unless they're outliers. And if they're wrong, they're not outliers. You see what I'm getting at there, friends? Good. But a defective test, for example, a defective test does happen. As Tiffany said, it does happen. False positives do happen. So one of the things you'll do is you'll analyze this in your last project. But 2 false positives happening is pretty rare. 1 false positive happening to 1 person, for example. Yeah. But Lance had 6 positive test results that were hidden. It's kind of hard to argue that when 6 out of 6 were all positive. Oh, they're all false positive. Or you just broke my heart because I supported you for a decade. Yeah, I cried a little bit about that. Anyway, so you dump them if you can prove the data's flawed. If you can prove the data's flawed. What if it's not? Then I'm back to how these guys are feeling about that. Shelby and Daniel, I don't want to throw away data points. I don't either. So what do we do with outliers? What do we do with them if it's not flawed? What if it's legit data? Give you an example. In think it was like 89, early 90s maybe, there was a field track, road and track test done. Miles per gallon, average miles per gallon done on a class of cars. They'll often do this. They'll test like 12 or 13 or 14 cars to see, you know, things like acceleration, braking distance, and all that stuff. And one of the things tested is average fuel economy, miles per gallon. And they take 20 of the cars, fill them up with the same amount of gas, they go drive them until they're empty on the same track. And a bunch of these cars are all in the same class, the same size of car. I think it was 4-door station wagons. Remember station wagons? They call them SUVs now. So 4-door station wagons, and they were all getting like routinely like 18, 19, 20 miles per gallon. And then the Buick Estate wagon was hitting like 25, 26 on average. And the drivers, the testers, what the hell's going on? Like all these cars have the same engine. They're all like V6s. The cars weigh the same. They're looking at every possible variable they can on the cars, and everything's the same. But they have this outlier chunk of cars that are getting 26 miles per gallon, where everybody else is getting 19. Do we throw out the Buick Estate wagon? No. Do we average the whole thing together and say on average four-door? If you guys are shaking your heads no. On average 4-door station wagons have this average? No, we shouldn't do that either because you're using the outliers to calculate the average, so you shouldn't do that.
Put them in their own categories.
Say that again, Tim?
Put them in their own categories.
You asked the question.
They're not related.
Maybe the outliers are trying to show us something. That gets 4 on smile. Because sometimes the outliers do show us something we're not looking for. So you don't throw away those Buick Estate wagons. You say, okay, what the hell's going on? I mean, essentially the engine's being made by the same engine manufacturer that's in that car over there. So it's arguably the same engine. John, what are you thinking?
Driver.
Driver, yeah.
No, they control for that as well by using the same drivers mixed around. Good, good. Keep thinking, keep thinking.
Axles.
The axles. Well, tell me about the axles.
Maybe they just don't have as much set aside.
Control for it. Very good. Friction. Friction would slow it down, but they control for that as well. Good. More.
Air pressure in the tires.
And that's what it was. The Buick Estate wagon recommended a higher air pressure using the same tires as every other car in the test. But they didn't catch that until months after they published the results. That's what was causing it. So it turns out the Buick Estate wagon was exactly the same as everybody else, and when retested with the normal air pressure, the mileage came right back down to what it should have been. But because of, this is what they tell you, keep your tires inflated to the maximum amount, or the maximum recommended amount, because you get better mileage. And they basically proved that in that test. So but that's what it is. The outliers are trying to tell us something. Don't throw them out. Go find out what's going on. Go find out what's going on. Does that kind of make sense? Ish, if you will. Now, that's fantastic. But why do we care about that? Well, I'm going to leave you with one more thing to think about before I kick you out of here for a break, because you're getting that glazed look. My son started riding his bike, I think it was just before he was 3 years old. Just before he was 3 years old. And it blew my mind. It blew my mind. Just watching him pedal away that day, just mind-boggling. Here he goes. The rest of his life, boom, go. And then I said, this is weird. I called my mom, I'm like, Mom, when did I start riding my bike? And she's like, oh, I think you were like 5 or 6. This is like first grade. I started riding this bike half the time it took me to ride my bike. So now I've got 2 data points, right? I've got the time. I'm going to come over here if it's okay with you guys. So we've got let's put this as time until bikes ridden. Why not? Birth. We'll do it in years. 1, 2, 3, 4, 5, 6. Okay, so here's me. There's me. Here's Max. So I look at that and I'm like, okay, 2 data points doesn't tell me a whole lot. So I was curious, and I'm a dork. So I started calling my friends from back east. I'm like, dude, when did you guys start riding a bike? All of them told me the same thing. How the hell do I remember that? They're like, wait, let me call my mom. So they all started calling their parents, and I started realizing something. that all of my friends were essentially right around here too. Some were a little bit before me, some were a little bit after me, but we were all pretty much, I'm exaggerating a little bit with that many friends, I was that young. And I don't stay in touch with that many friends right now. But the idea was that we were all clustered around this general area. So what did I start looking at Max as? Definitely an outlier. I thought to myself, holy crap, Max has got to be an outlier because he's so far left. However you want to look at it measure-wise. We see this on the... We can, yes. So Christina?
Yeah, it depends on what is his age group doing.
And that's what I started looking at. We started, because I remember when Owen, his best friend Owen, started riding a bike. And he rode a bike before Max. But he's also 3 months older than Max. And he rode his bike essentially 2 months before Max did. So Max was like, Owen rode his bike first. I'm like, yes, but you rode your bike a percentage first. And he's like, looking at me like I got 3 heads. I'm like, oh, that's right, you're 3 years old. You don't get that yet. So essentially, Owen rode his bike the same time Max did. Lily rode her bike actually even before. And then there was Max Chen, and there was, who else was in there? Caden was in there. And when I started putting the data points in, I started noticing that Max was an outlier when compared to my data set. But he was completely normal when compared with his friends' data sets. So then I had a conclusion. The outliers not only showed us something, they showed me that that data point belongs somewhere else. And this was going back to what Patrick said. And a couple of you guys were nodding on. We looked at our height guesses. We may have had 2 different data sets there. And what looks like outliers might just not belong here, it belongs over here. And then the statistician then asks themselves, okay, why? Why are there 2 data sets?
Who are these Max's friends?
The red ones are Max's friends, the green ones are my friends.
And are their fathers your friends?
No, the mothers are Jen's friends.
Okay, so I know you ride bikes.
I do, and some of them do too, and some of the moms don't.
Probably they're going to be
But
prone to...
Technology has changed. There's
What technology?
Balance bikes have rules, and kids are learning how to balance first and then just add the wheels in.
Boom.
Totally, those Strider bikes.
The Strider bikes. These things, I'm convinced I can explain this. And Madeline just did, and I did it too. These things are called Strider bikes. It's a bike with handlebars and a front wheel and a back wheel and no cranks. That's set very low to the ground so the kids can walk on them.
Oh, this is sweet.
Totally awesome. Max was on that at age 2, maybe even before, I can't remember exactly. He was also riding on my tag-along from age 2, which don't do that, FYI. He fell off a couple times, that's kind of terrifying. Yeah, he didn't know to hold on with both hands. I had to tell him that after a while. I heard this thump and I turned around, my son's laying on the back. I'm like, shh. And he's like, Daddy, I was looking at the card. I'm like, that's totally fine, just hold on. Now this is on YouTube. Charles will be taken away from me. Anyway, but the Strider bikes, I'm convinced this is what did it. Because we learned on training wheel bikes. There is nothing worse for developing balance than a set of training wheels. Because there's no balance involved. You're relying on the bike to balance for you. Watching Max, he's on the Strider bike, and he's 2 going like this. And then he's 2.5, and he's kicking and gliding. And then he's kicking and putting his feet up. He's putting his feet up on the crossbar going down. You know? That directly translates to putting him on a 2-wheel bike with cranks. All he's got to do is get it up to speed, and then he can keep his balance just fine. So I think this makes perfect sense when you view it, but that's another case of the outlier trying to show you something. Yes, he's an outlier. Do I ignore the fact? No, I want to know why. I want to know why these kids. It could be also the fact we gave him a Strider bike because we like biking.
Are they pretty popular, the Strider bikes?
They seem to be.
Super popular.
I'll give you a hint though.
Okay.
They're also very expensive. They're made of wood. They're very, very nice. We made one. We went to one of those like child thrift store things and got a Fisher Price bike for $5.
Yeah, we did too.
And cut the cranks off. Yeah, we did too. Works exactly the same. Just FYI, probably easier to work on too. So if anybody's thinking about getting one, you can totally get one. They're really cute. I'm sure the resale value is quite nice too. They also look like furniture. But I was like, I'm not gonna pay $75 for one of these things. I'm gonna pay $5 to pick a heck.
Tristan just railed on his. There were chips out of it.
Oh yeah, and the Fisher Price one was bomb-proof. I mean, we gave it to somebody else when we were done with it.
We gave it to somebody else too.
For sure.
Yeah.
But that's the thing. See, statistics, it's easy to throw numbers into a formula and pop an answer out and be like, here it is. But a much tougher question is why? Why is that unusual? And now the beautiful thing about this is what 244 is based off of. This tells you whether or not you should believe if a drug is working. This tells you whether or not you should believe if breast cancer rates are dropping after drinking green tea. This tells you whether you should drink caffeine during submax exercise if you're a mid-to-level elite cyclist. FYI, you should, because it seems to lower heart rate. So there's all kinds of things that if you get outliers in data sets, it doesn't mean something's wrong. It could mean something that's wrong. It could mean something's wrong. but it can also mean something is different. And then it's up to you to kind of figure out what that something is. Rad, huh?
Pretty cool, pretty cool.
All right. You woke up a little bit on that one.
Mhm.
I said, whenever I mention Max in this class, we'll wake up. It's kind of cute, so I'll just keep bringing him up. That'll work out. But don't take 5. I'm going to sprint back up and get my freaking stand. All out of sorts. I apologize. I feel terrible about that. I will go up and get my stand at my old building.